Alright, I just want to show you guys the finished product here. I took these off of some of those current sensor modules, the 712s or whatever, because I like to use them in the breadboards. So I took the screw terminals off, put them on here. So here's the solenoid, which I had taped here, and solenoid comes off of here. Power goes in. Here's the reed switch. Show you that it works. Alright, so let's go over the circuit a little bit. It's pretty simple, but there are some interesting things about it. The magnetic reed switch here is driving, or is switching on actually, this transistor. And as I said, when I originally made this circuit, I didn't even use a circuit. I put the reed switch directly in line with the solenoid and a battery, a 12-volt battery, and as soon as I actuated it, the reed switch just fused together. It was too much current for it. So I wanted to be able to use it, turn the thing on without consuming a lot of current. So this is the setup that does it. I'll explain all this. So now we've got when we hit the switch, we basically complete this circuit here through this emitter base junction. These two resistors act as a voltage divider. So there's a voltage across this resistor that supplies this junction, and then this is a current limiting resistor. So this restricts the current that's allowed through here, which is really what is important. You need a certain voltage to turn it on, but you also want to make sure that you don't have a lot of current flowing through it. Just like with an LED, when you put current limiting resistors on there, same kind of thing. So when that's on, let's see. Yeah, there we go. So we got that small current flowing through there. And then when the transistor's on, it allows the heavy current to flow from the emitter to the collector. And current always flows from minus to plus, by the way, in case you didn't know that. And then this transistor, the MJE182, can handle more than enough current. But picking your components right is also obviously very important, because this thing is rated at 1 amp, this solenoid, but I measured it at 1.5 amps, so it was pulling a lot more than an amp. Alright, so yeah, there's the current flow for the solenoid once the transistor is on. And there's the whole thing. So both of these are happening at the same time. There's a limited current flow going in this direction, and then there's a much faster current flow going in this direction, all in the same wire. Except when this thing is on, this switch sees none of this current up here, which was the whole point of this, was to isolate this from having to suffer from a heavy load. Now, the protection diode. What happens with a solenoid is a coil, which is essentially an inductor. And what happens with inductors is once they're fully charged, they build up a magnetic field around them, which is the case with any wire. When you move electricity through a wire, it builds a magnetic field around the wire. But when it's in a coil configuration, it's a lot more potent, and it stores it a lot more densely, I guess. It actually kind of stores it. So you can kind of think of it as resistance, natural resistance in the wire, but the resistance is in the form of magnetism, electromagnetism. So when the coil is charged, there's a magnetic field around it that is opposing the current. And when you take power off of the solenoid or off of the coil, that magnetic field is going to want to dissipate back into the coil, but in the opposite direction. What that would do is that would backfeed that transistor back into the collector, and it could potentially blow the transistor, because the voltage can be even in the thousands of volts initially for only a fraction of a second, but that could be enough time to blow a transistor depending on the transistor. Or if it's not, if it doesn't blow it, it could weaken it and it will, to where it'll eventually give out. So we put this diode here across the solenoid, so that when the power is cut off, the only place for electricity to go is in this direction, and that will dissipate the electricity back through the coil instead of allowing it to come down here through the transistor. So that's all that's for. Anyways, I hope you liked the video. If you did, please click on like. And as you can imagine, there are several uses for this circuit. For example, you could use it as a locking mechanism for a hidden compartment, or for child protecting doors that they shouldn't be getting into. You could also use it to actuate another switch or a button, or whatever else you can think of. Thank you again for watching, and we'll see you next time.